Imagine the quiet hush of a late night as you gaze at the unseen canvas of the universe above. For millennia, humanity has been drawn to the cosmic spectacle, charting constellations and weaving myths into the tapestry of stars. In our modern age, we've built colossal telescopes, launched probes, and even touched lunar dust, gaining profound insights into the mechanics of the cosmos. We understand the life cycle of stars, the birth of galaxies, and the intricate ballet of celestial bodies. Yet, for every answer we uncover, countless new, more profound questions unfurl, stretching beyond our current grasp and revealing layers of mystery that beckon with an ethereal glow. Tonight, we invite you on a different kind of cosmic journey. This is not a frantic pursuit of answers, but a contemplative drift through the very limits of human understanding, an opportunity to gently explore the universe's most enigmatic inquiries. We will embrace the unknown, allowing its vastness to cradle our minds rather than provoke them. This exploration is about recognizing that despite our astonishing scientific progress, the cosmos holds fundamental unknowns, not merely puzzles, but deep, unsettling inquiries that challenge our most basic assumptions about reality, time, and existence itself. We'll delve into these profound gaps in our knowledge, not to ignite anxiety, but to foster a sense of awe and quiet contemplation. Think of it as a cosmic lullaby, where the most unsettling questions become soothing whispers. These aren't just scientific curiosities, they are existential inquiries that resonate with the deepest parts of our being. They invite humility, reminding us of our small but significant place in the grand scheme. They ignite wonder, painting a picture of a universe far more intricate and mysterious than we could ever fully grasp. And perhaps surprisingly, they offer a strange, profound calm. By acknowledging the vastness of what we don't know, by surrendering to the intellectual edges of our perception, we can find a unique peace. It's a feeling akin to floating in a vast, warm ocean, allowing our minds to drift gently through the grand, unfinished tapestry of the unknown. There's a certain liberation in admitting that not everything must be known, not everything must be explained. Take a moment now to simply allow this vastness, this beautiful, echoing unknown, to settle around you, to quiet the busy chatter of your everyday thoughts. Just breathe and absorb the gentle mystery. As we drift through these thoughts, letting our minds relax into the cosmic unknown, let's begin with one of the most poignant questions that echoes across the vastness of space. Are we truly alone in this immense universe? And if not, why the profound silence? Consider the sheer, unfathomable scale of our universe. Our Milky Way galaxy alone hosts hundreds of billions of stars, and there are trillions of galaxies in the observable universe. Within each galaxy, many stars likely host planets, with a significant fraction potentially residing in their star's habitable zone, where conditions might allow for liquid water, the essential ingredient for life as we know it. Given these staggering numbers, it seems almost statistically impossible that Earth is the only planet teeming with life, especially intelligent life. Yet, as our most sensitive radio telescopes scan the heavens, all we are met with is a profound, echoing silence. This profound contradiction lies at the heart of what is famously known as the Fermi Paradox. Named after physicist Enrico Fermi, who famously asked, "Where is everybody?" In 1950, this paradox highlights the stark discrepancy between the high probability of extraterrestrial intelligent life existing and the profound lack of observational evidence. If life is a natural outcome of cosmic evolution, and if even a small fraction of intelligent civilizations survive long enough to develop interstellar travel or communication, then why haven't we detected any signs of them? Given the immense age of the universe, nearly 14 billion years, and countless opportunities for civilizations to arise and leave a trace, their absence, their profound silence is deeply unsettling, or perhaps strangely comforting. The implications of this cosmic silence are vast and varied. Perhaps advanced civilizations simply self-destruct before reaching interstellar capability, falling victim to technological hubris or internal conflict. This suggests a great filter, an immense barrier to life's development, either in our past or, chillingly, in our future. Another possibility is that we are simply not looking in the right way or for the right kind of signals. Perhaps advanced civilizations communicate in ways we cannot yet conceive, or have transcended the need for physical structures and communication as we understand it. Or just perhaps, they are out there, but have chosen not to interact, observing us from afar, like cosmic anthropologists. The very thought invites a quiet humility, suggesting our place in the universe might be more unique and fragile than we often assume, or perhaps that something vast and unknowable limits the spread of intelligent life. Let your mind gently ponder this profound cosmic quiet, letting the silence cradle your thoughts. Whether this pervasive silence is due to vast distances, our limitations, or something more profound, it naturally leads us to ponder the very fabric of existence. As we contemplate this grand quietude, our minds often turn to what actually makes up the universe around us, and it turns out much of it remains unseen, unheard, and profoundly unknown, guiding our journey to the hidden architects of the cosmos. Imagine a vast, intricate cosmic ballet, where galaxies pirouette and cluster in enormous filaments. In this grand performance, a substantial portion of the dancers are completely invisible to us, their presence betrayed only by their powerful gravitational influence on everything we can perceive, on the visible stars and luminous gas. Our telescopes cannot directly see them. Our instruments cannot detect them. Yet, the evidence for their existence is as compelling as the gravity that binds our very feet to the earth. This unseen, enigmatic participant in the cosmic dance is what we call dark matter. The concept first emerged from observations of how galaxies rotate. Stars in the outer regions of galaxies orbit just as fast, or even faster, than those closer to the core. This wouldn't be possible if only visible matter accounted for all the mass. The only way to explain this is if there's far more mass present than we can see. Mass that exerts a gravitational pull but doesn't emit, absorb, or reflect light. Further evidence comes from how galaxies cluster, how light bends around massive structures, and from the cosmic microwave background. All these observations consistently point to the same conclusion: an immense amount of missing mass. Scientists now estimate that dark matter makes up an astonishing 27% of the universe's total mass and energy, acting like a cosmic scaffold, providing the gravitational glue that holds galaxies and galaxy clusters together. Without it, the universe as we know it would simply fly apart. The implications of this invisible hand are profound. If nearly 85% of the universe's matter is composed of something we cannot detect, something that doesn't interact with light or normal matter, what does that truly mean for our comprehension of reality? Is dark matter composed of a new, exotic type of particle, like WIMPs, so elusive that they pass right through us and entire planets without leaving a trace? Or does its existence point to a fundamental flaw in our current understanding of gravity itself, suggesting our models might be incomplete on cosmic scales? The universe, then, is not what it appears to be. It is overwhelmingly populated by this unseen, unfelt presence, silently shaping the grand cosmic structures we observe. This challenges our very notion of what is real and detectable. The fact that the dominant form of matter in the cosmos remains a complete mystery should humble us, and perhaps, surprisingly, offer a moment of quiet contemplation. Imagine this vast, hidden architecture, silently dictating the rhythm of the universe, a presence we feel but cannot see. Take a slow, deep breath and allow yourself to wonder at this invisible scaffold. This invisible architecture, holding galaxies together, is only one part of the cosmic puzzle, a silent, pervasive force. Yet, there's another unseen force, even more mysterious, that's actively pushing the universe apart, accelerating its expansion into an ever-expanding void. For many decades, cosmology held a clear vision of the universe's destiny. Following the Big Bang, the pull of gravity, exerted by all matter, was expected to gradually slow the expansion. Eventually, it might even halt, perhaps leading to a big crunch, or at least expanding at an ever-diminishing rate. But in the late 90s, a startling discovery shattered this. Observations of distant supernovae revealed that the universe's expansion isn't slowing, it's actually speeding up, accelerating into an unknown future at an ever-increasing pace. This revelation sent shockwaves through the scientific community. This unexpected, counterintuitive acceleration led to the hypothesis of dark energy. It is an enigmatic, repulsive force permeating all of space that acts in direct opposition to gravity, causing the universe to expand at an ever-increasing rate. Unlike dark matter, which is unseen mass, dark energy is thought to be an inherent property of space itself, a kind of anti-gravitational pressure. Scientists now believe that dark energy constitutes an astonishing 68% of the total energy density of the observable universe, making it the dominant component of our cosmos. It is the ultimate driving force, shaping the universe's destiny. We cannot directly observe it, nor definitively measure it in a lab, but its effects on the largest scales of the universe are unmistakable and profound. It is as if the vacuum of space is not truly empty, but filled with an inherent, repulsive energy pushing everything apart. The implications of dark energy's existence are vast and deeply unsettling. What precisely is this enigmatic energy? Is it truly a cosmological constant, a fixed property of space that Einstein once proposed and then discarded? Or is it a dynamic energy field, constantly changing and evolving, perhaps hinting at deeper dimensions or new physics beyond our current grasp? Its existence fundamentally challenges our understanding of gravity, the very fabric of space-time, and the ultimate fate of the universe. If dark energy continues to dominate, the universe might be destined for a big rip, where the expansion accelerates so violently that even atoms are eventually torn apart. Or perhaps a big freeze, leading to a lonely, cold, and utterly empty cosmos where all stars have died out, and galaxies are stretched so far apart they become forever invisible. The universe isn't merely expanding, it's being actively stretched, propelled by a force we barely comprehend. Allow this slow, relentless, and accelerating expansion to drift through your mind, a quiet reminder of the universe's ceaseless evolution. As the universe expands faster and faster, propelled by this enigmatic, unseen force, we're naturally led to wonder about its ultimate genesis. What ignited this expansion in the first place? What was there, if anything, before the Big Bang, before the very concept of space and time as we know them came into being? The Big Bang theory stands as the cornerstone of modern cosmology, a remarkably successful framework describing our universe's rapid expansion from an unimaginably hot, dense state, approximately 13.8 billion years ago. It explains the universe's expansion, the formation of light elements, and the cosmic microwave background radiation. It tells us how matter formed, stars ignited, and galaxies gathered. However, the Big Bang theory describes the evolution of the universe from that initial singularity. It does not and cannot explain the origin of that initial state itself. It speaks of the universe's beginning point in time, but remains profoundly silent on the singularity's cause or what transpired before it. This is one of cosmology's most profound and enduring boundaries. Our current laws of physics, the very frameworks we use to understand space, time, and matter, fundamentally break down at the Big Bang's singularity. This means we cannot use them to describe what existed prior to that moment, nor can we truly understand the singularity itself. Was it truly a moment of absolute nothingness, a spontaneous genesis from a void beyond comprehension? Was it a different phase of matter or energy, something so alien to our current physics that it defies our descriptive capabilities? Perhaps most unsettlingly, was time itself even a meaningful concept before the Big Bang? If time began with the Big Bang, then the very question, what came before, loses its logical footing, yet it persists as an irresistible inquiry, a whisper from the very edge of reality. The implications of this before the bang mystery are vast, reaching into the core of philosophical inquiry and challenging our intuitive sense of causality, the idea that everything must have a preceding cause. If the universe emerged from a state that defies our understanding of cause and effect, then our notions of genesis and ultimate beginnings are thrown into profound question. Some theoretical models propose a cyclical universe where big bangs are followed by big crunches in an endless cosmic dance of expansion and contraction, making our universe merely one iteration in an eternal cycle. Other, more recent theories suggest that our universe might have bubbled off or emerged from a multiverse, a larger, more fundamental entity constantly giving birth to countless other universes, each perhaps with unique laws. The very idea of something existing outside or prior to our universe's temporal and spatial boundaries forces us to expand our conceptual horizons, to imagine realms beyond our direct experience. It's a deep question that leaves us in a realm where the very notion of before loses its conventional meaning, inviting a quiet surrender to the incomprehensible. Gently consider the concept of ultimate beginnings, allowing the mystery to settle softly in your mind. The question of what existed before our universe's dawn, what primed the cosmic stage for its grand unfolding, naturally leads us to ponder the remarkably precise conditions that allowed our universe to emerge. Conditions so exquisitely specific, so delicately balanced, that they sometimes seem almost deliberately crafted, hinting at a universe not just born, but potentially beautifully tuned. Imagine a vast, intricate cosmic machine, inconceivably complex with thousands of interlinked dials and levers, each representing a fundamental physical constant or initial condition of the universe. Now, picture that if even a single dial were off by an infinitesimal fraction, a mere decimal point out of place, the entire machine would utterly fail to function. It wouldn't just produce a slightly different output, it wouldn't exist at all. This is the astonishing scenario we face when we examine our universe, where countless fundamental physical constants seem to be set with breathtaking precision, allowing for the very existence of stars, planets, and, most remarkably, life itself. This is the profound mystery of cosmic fine-tuning. Scientists have identified numerous fundamental constants in physics that appear to be exquisitely tuned for the existence of complexity and life. For instance, consider the strength of the electromagnetic force. If slightly weaker, atoms wouldn't form. If stronger, electrons would pull into the nucleus. The gravitational constant. If stronger, the universe would collapse too quickly. If weaker, galaxies wouldn't coalesce. The initial expansion rate of the universe. Too fast, no structures would form. Too slow, it would collapse too quickly. The mass of protons and neutrons, the precise energy levels of carbon atoms, the amount of dark energy, the list goes on. If these values were even infinitesimally different, by minuscule amounts, stars wouldn't ignite, atoms wouldn't bind, or the universe would either collapse too quickly or expand too fast for any form of stable, complex structure, let alone life, to arise. The implications of this astonishing fine-tuning are among the most debated and philosophically rich in all of cosmology. Is this merely an unimaginably improbable cosmic accident? An astounding stroke of sheer luck that we happen to inhabit the one universe out of countless possibilities that supports our existence? This view, while scientifically viable, often feels intuitively unsatisfying. Does it instead suggest evidence of a deliberate design, hinting at a creator or intelligence guiding the parameters of the cosmos? This teleological argument, while compelling to some, often falls outside empirical scientific investigation, or perhaps most powerfully within the scientific community. Is it a compelling argument for the existence of a multiverse? In this scenario, our universe is just one among an enormous, perhaps infinite number of other universes, each born with different physical laws and fundamental constants. If every possible combination exists across countless universes, then it becomes inevitable that at least one would have the precise conditions necessary for life. In this view, we simply reside in the universe that happens to support us. This concept profoundly challenges our conventional understanding of contingency and necessity, inviting us to consider a reality far grander. Let the sheer improbability or the quiet inevitability of fine-tuning wash over you, a gentle paradox to drift through your thoughts. This astonishing fine-tuning, whether by chance or design, leaves us wondering if our universe is truly unique, or if it's merely one ripple in a much larger unseen cosmic ocean, part of an infinite collection of possibilities. Perhaps we can find clues to its origins in the very first light of our universe, the ancient echoes that still linger, holding subtle patterns we don't fully comprehend. Imagine listening to an ancient cosmic hum, the oldest light in the universe, an afterglow from the Big Bang itself. This cosmic microwave background is the thermal radiation left over from the time when the universe was just 380,000 years old, when photons first streamed freely, providing a baby picture of our cosmos. While remarkably uniform, a testament to the smoothness of the early universe, within its gentle, consistent hum, scientists have painstakingly detected incredibly faint whispers, subtle temperature variations, tiny ripples in the fabric of space-time that defy easy explanation, holding secrets from the very beginning. The CMB is an invaluable tool for cosmologists. Its near-perfect uniformity across the sky strongly supports the Big Bang and inflationary cosmology. The tiny temperature fluctuations within it, mere microkelvins different from the average, are crucial. They represent the seeds of all large-scale structures we see today, the proto-galaxies and clusters. However, as our observational instruments have become exquisitely precise, they have revealed some perplexing, larger-scale anomalies within this tapestry. These include the cold spot, a vast, unusually cold region of the sky, significantly colder than predictions, spanning billions of light years. Another intriguing, controversial anomaly is the axis of evil, a peculiar alignment of some of the largest temperature variations in the CMB with the plane of our solar system, which seems statistically improbable and contradicts the expectation that these fluctuations should be randomly distributed. These discrepancies, though subtle, suggest something more complex or unexpected about the very early universe or our place within it. The implications of these CMB anomalies are profound. Do they suggest physics beyond the standard model of particle physics and cosmology, hinting at fundamental forces or particles we have yet to discover? Could these large-scale patterns be hints of interactions with other universes, or imprints from processes that occurred even before the Big Bang itself, perhaps remnants of a multiverse collision or a preceding cosmic epoch? Or are they simply statistical flukes, instances of patterns emerging from random data that we are overinterpreting, much like seeing familiar shapes in clouds? The cold spot, for example, could be due to a supervoid, but even that explanation struggles to fully account for its depth. The axis of evil is particularly unsettling because it seems to tie global cosmic structure to our local position, which goes against the Copernican principle. These faint, ancient echoes continue to challenge our most robust models of the early universe, leaving us with a sense of wonder and intellectual humility. Allow these ancient whispers, these subtle inconsistencies, to gently soothe your thoughts, reminding you of the universe's many untold stories. As we decode these ancient whispers, these subtle echoes from the dawn of time, we're reminded that space holds secrets not just from the beginning of time, but also from its most extreme corners, places where even light cannot escape, and where the very rules of physics seem to break down. Imagine the most extreme cosmic abyss, an object so dense that its gravity is inescapable, warping space-time into an ultimate prison. We are speaking of black holes, the universe's most enigmatic objects. They are defined by their event horizon, a one-way boundary beyond which nothing, not even light, can escape. From the outside, they appear simple, characterized only by their mass, spin, and charge. But what happens to everything that falls into this cosmic maw? Stars, gas, even light itself. If objects fall in, taking their intricate information with them, and if black holes eventually evaporate by emitting faint Hawking radiation over vast cosmic timescales, where does that information go? Does it simply vanish from existence? This question lies at the heart of the black hole information paradox, a fundamental conflict in modern physics. It represents a direct clash between two pillars of our scientific understanding: Albert Einstein's general relativity, which describes gravity and black holes, and quantum mechanics, which states that information can never truly be destroyed, only transformed. If something falls into a black hole, and the black hole eventually evaporates, the information contained within the fallen object seems to vanish from the universe, violating a core principle of quantum theory. It's as if you burned a book, and not only did the ashes carry no trace of the story, but the story itself ceased to exist anywhere. The implications of this paradox are truly profound, striking at the very core of our understanding of reality and causality. If information is truly lost within black holes, it would mean that quantum mechanics, as we know it, is fundamentally incomplete or incorrect, necessitating a complete overhaul of our understanding of the universe at its most basic level. Conversely, if information somehow escapes, perhaps encoded on the event horizon itself, it would imply a violation or deep modification of general relativity. Resolving this paradox is not merely an academic exercise. It is seen as the key to developing a unified theory of quantum gravity, a grand framework that can seamlessly merge general relativity with quantum mechanics, a holy grail of physics. The mystery of what happens beyond the event horizon, what secrets are held within these cosmic abysses, continues to challenge our fundamental understanding of reality, causality, and the conservation of information. Gently ponder the secrets held within these cosmic abysses, the silent, ultimate shredders of cosmic data. The idea of information being encoded, lost, or perhaps mysteriously preserved at the very edge of oblivion leads us to ponder how information, and indeed reality itself, is constructed at the most fundamental, subatomic levels, a realm where reality behaves in ways that utterly defy our everyday intuition, where things can be in two places at once, and where the act of simply observing something can irrevocably change its very essence. Imagine a peculiar, almost magical connection between two tiny, invisible particles. If you were to observe one and find it spinning clockwise, its twin, no matter how vast the distance separating them, across a room or across the galaxy, would instantaneously be spinning counterclockwise. There's no detectable signal traveling between them, no apparent communication, yet their states are inextricably linked, as if by an invisible, instantaneous thread. This isn't science fiction, it's a baffling reality in the quantum world, famously dubbed spooky action at a distance by Albert Einstein. This is the bewildering reality of quantum entanglement. Quantum entanglement describes a fundamental property where two or more particles become intrinsically linked, sharing the same quantum state, regardless of separation. When you measure a property of one entangled particle, the corresponding property of its partner instantly becomes determined. This bothered Einstein, as it seemed to imply information traveling faster than light, violating his theory of special relativity. He believed there must be hidden variables, predetermining outcomes, but experiments, particularly those building on John Bell's theorem, have largely disproven this, confirming the spooky action is real. The particles truly seem to be non-locally connected, behaving as if they are part of a single, indivisible quantum system, even when spatially separated. The implications of quantum entanglement are vast and fundamentally challenge our classical understanding of reality and locality, the idea that an object can only be influenced by its immediate surroundings. Entanglement, however, suggests a deeper, interconnected fabric of reality where influence seems to transcend spatial separation without any physical medium. Does this phenomenon imply a hidden, underlying layer to the universe, a profound interconnectedness that we are only just beginning to glimpse? Could it offer theoretical pathways for communication or computation far beyond our current capabilities? perhaps even hinting at the universe as an immense, interconnected quantum computer? Or is it simply a fundamental, irreducible weirdness of existence at its smallest scales? A feature of reality that forces us to abandon our classical intuitions about how things should behave. Entanglement suggests a universe far more mysterious, subtle, and profoundly interconnected than our everyday experience reveals, hinting that the very fabric of reality at its most fundamental level operates on principles that defy our common sense. Allow the subtle, unseen connections of the universe, this spooky action, to gently flow through your thoughts, a quiet reminder of how much lies beyond our immediate grasp. This mysterious connection hints at a universe far more interconnected than we imagine, and it begs another question. How does merely observing these quantum ripples influence their very existence, seemingly forcing them to choose a single reality from a sea of possibilities? Imagine a tiny, unseen entity existing in a blurred state, simultaneously occupying multiple locations at once. In our everyday world, observing something doesn't fundamentally change it. But at the incredibly tiny, subatomic quantum level, reality behaves in a truly bizarre and counterintuitive way. The very act of looking, of interacting with, or simply measuring a particle seems to force reality to make up its mind. Particles that exist as waves of possibilities suddenly collapse into a single definite state only when they are observed or measured. It's as if the universe is playing hide and seek and only reveals its true position when it knows it's being watched. This profound mystery lies at the core of what is known as the measurement problem and the observer effect in quantum mechanics. Before a quantum particle is observed, it exists in a superposition, simultaneously being in multiple states. The famous double-slit experiment illustrates this vividly. Electrons fired at two slits behave like waves, creating an interference pattern, implying they went through both slits at once. However, the moment you try to observe which slit the electron goes through, the wave pattern disappears, and the electrons suddenly behave like discrete particles, each going through only one slit. The act of measurement, the interaction of the observer with the system, seems to collapse the wave function, forcing the particle to choose a single definite state from its previously ambiguous existence. The implications of this phenomenon are deeply unsettling and have fueled decades of intense debate among physicists and philosophers. What, precisely, constitutes an observer or a measurement? Does it have to be a conscious being or merely an interaction with the environment? Does reality only become concrete, only decide its state when it is observed or interacted with? This raises profound philosophical questions about the nature of reality itself. Is objective reality something that exists independently of our perception, or is it fundamentally intertwined with our conscious awareness or the act of measurement? Some interpretations, like the Copenhagen interpretation, accept this collapse as a fundamental, unexplained aspect. Other interpretations, like the many worlds, suggest the wave function never collapses. Instead, at every measurement, the universe splits into multiple parallel realities. The measurement problem suggests that consciousness, or at least interaction, might play a surprisingly fundamental and active role in shaping the physical world, challenging our classical separation of mind and matter. Gently contemplate the power of perception, the gentle act of witnessing, to drift through your thoughts, a silent reminder that reality might be far more fluid than we assume. If our observation, our very presence, appears to shape reality, even at a microscopic level, it speaks to a profound connection between consciousness and the cosmos. But what about time itself? Does it flow uniquely, or can it be bent, perhaps even reversed, in some deeper, unfathomable way? We all share a universal, deeply ingrained experience of time. It feels like an undeniable, relentless, and unidirectional flow, an irreversible progression from the past through the present and inexorably into the future. Our memories are always of what was, and anticipation is always of what will be. We age, we learn, we grow, and we observe processes like a dropped glass shattering, never spontaneously reassembling. This intuitive arrow of time seems woven into the very fabric of our existence. Yet when we delve into the fundamental laws of physics that govern the universe, we encounter a profound paradox. Most of these laws don't distinguish between past and future. They work just as well if time is reversed. This is the perplexing mystery of the arrow of time. Consider Newton's laws of motion. If you filmed a billiard ball collision and played it in reverse, the laws of physics would still appear to hold true. The same applies to Maxwell's equations for electromagnetism, and even the equations of general relativity, which govern gravity and spacetime. These fundamental laws are largely time-symmetric, meaning they don't prescribe a direction for time. So, why do we experience time as flowing only forward? The most widely accepted explanation comes not from individual particle laws, but from thermodynamics, specifically the second law of thermodynamics and the concept of entropy. Entropy is a measure of disorder. The second law states that the total entropy of an isolated system can only increase over time. Highly ordered states are improbable. Disordered states are far more likely. A tidy room naturally becomes messy. A broken teacup will never spontaneously reassemble because that would decrease entropy. So, time flows in the direction that entropy increases, moving from order to disorder. The implications of this entropic arrow of time are deep and far-reaching. Why then did the universe begin in such an incredibly low entropy, highly ordered, and incredibly compact state? This initial low entropy is the fundamental engine that allows for the very existence of an arrow of time in our universe. If the universe started in a high entropy state, there would be no progression, no evolution, no formation of complex structures, and thus no life to observe anything. Could time ever truly reverse? Perhaps in a distant future if the universe were to contract, or might it simply branch into different directions, as some speculative theories suggest? Does the arrow of time depend on the vast, evolving scale of the universe? Or is it a more localized, emergent phenomenon that only appears at our macroscopic level? This mystery delves not only into the very nature of existence, but also into how we perceive our place within the grand unfolding of the cosmos. It suggests that our experience of time is deeply connected to the universe's overall journey from order to increasing disorder. Allow the gentle, inexorable flow of time to carry you, a soothing current in the vast ocean of existence. The unwavering march of time, powered by the relentless increase of cosmic entropy, brings us closer to the most fundamental questions of existence, including the very emergence of life from seemingly inert matter. How did we, living beings capable of pondering these mysteries, come to be in a universe that seems indifferent to our existence? Consider the grand tapestry of the universe. For the most part, it is a vast, cold, empty expanse, primarily composed of the simplest elements, hydrogen and helium. It is punctuated by stars, and more rarely by rocky planets. Yet, on at least one of these unremarkable planets, our own Earth, an astonishing and profoundly improbable transformation occurred. Simple, non-living chemicals, energized by primordial forces, somehow spontaneously organized themselves into the first self-replicating, evolving life forms. This was the moment the universe, in one small corner, began to awaken to itself. It is a leap from the inanimate to the animate, from mere chemistry to the possibility of consciousness, that remains one of the most compelling and elusive scientific mysteries. This is the profound mystery of abiogenesis, the natural process by which life arises from non-living matter. While Charles Darwin's theory of evolution explains how life diversifies, it does not, and was never intended to, explain how life itself began. That initial spark, that fundamental leap from complex chemistry to rudimentary biology, is what abiogenesis seeks to understand. Scientists are still painstakingly piecing together the puzzle, exploring various hypotheses. They investigate how simple inorganic molecules on early Earth, perhaps in volcanic vents or under meteorite bombardment, could have spontaneously formed more complex organic compounds like amino acids and nucleotides. Furthermore, They try to understand how these complex compounds then assembled into self-replicating structures, possibly with RNA serving as the first genetic material. Finally, the question remains of how these earliest protocells developed the ability to metabolize, compartmentalize themselves within primitive membranes, and reproduce. The conditions on early Earth were chaotic and energetic, but the precise series of events that led to the first living cell remains an enormous, gaping hole in our scientific narrative. The implications of solving the mystery of abiogenesis are monumental. Is life an inevitable consequence of physics and chemistry under certain conditions, meaning it might be a common occurrence throughout the cosmos, perhaps bubbling up on countless other planets? If so, the universe could be teeming with microbial life, even if intelligent life is rare. Or is life an incredibly rare fluke, a singularly improbable event that required an almost impossibly specific set of Goldilocks conditions, not just for a planet, but for the very fundamental laws of the entire universe to allow its emergence? The answer to abiogenesis holds profound clues to whether the cosmos is teeming with other beings, or if we are a solitary, miraculous island of sentience in a vast, empty ocean. It shapes our understanding of our uniqueness, or lack thereof, in the grand cosmic scheme. This mystery invites a gentle humility, reminding us of the fragility and wonder of our own existence, and the long, improbable journey that led to us. Gently contemplate the first stirrings of life, the primordial soup boiling with possibility, and the first faint whisper of being. From the chemical soup of ancient Earth to the complex neural networks of our brains, the emergence of life is a miracle. But what if that miracle, and indeed our entire reality, isn't quite what it seems? What if it's all part of a grander design, or perhaps a grander program? Imagine a civilization millions, even billions, of years more technologically advanced than our own. Their computational power would be incomprehensible, their ability to create virtual realities indistinguishable from physical reality. Such a civilization might be able to perfectly replicate an entire universe, complete with conscious beings like us, existing within it, utterly unaware of their simulated nature. Now, ponder this. Could our reality, the very world you perceive, the thoughts you think, the feelings you feel, be such a simulation? This is not just science fiction. It is a serious philosophical and scientific thought experiment, one that has gained increasing traction, leading us to question the fundamental nature of our existence. This is the core of the simulation hypothesis, most famously articulated by philosopher Nick Bostrom. He argues that it is highly probable we are living in a computer simulation, not due to direct evidence, but based on a logical trilemma. Bostrom posits that at least one of three propositions must be true. 1. Almost all advanced civilizations go extinct before developing simulation technology. 2. Advanced civilizations choose not to run such ancestor simulations. Or 3. We are almost certainly living in a simulation. Given humanity's rapid technological progress in developing increasingly realistic virtual worlds, the third possibility, he argues, becomes increasingly likely. If future humans eventually run countless incredibly detailed simulations of their past, then the sheer number of simulated realities would vastly outnumber the single base reality, making it statistically probable that any given conscious observer is more likely to be in a simulation. The implications of the simulation hypothesis are vast, unsettling, and profoundly challenge our most basic assumptions about reality, free will, consciousness, and the meaning of our lives. If our reality is simulated, what does that mean for our agency? Are our choices truly our own, or predetermined by the program? Could we ever detect glitches in the matrix, subtle inconsistencies betraying our simulated nature? Who are the programmers, and what is their purpose? This idea forces us to consider the nature of existence from a radically different perspective, blurring the lines between fundamental reality and constructed reality. It also opens questions about purpose. If we are simulated, Is there a purpose given to us, or must we create our own within the bounds of the simulation? The thought alone can be strangely liberating, allowing a sense of detachment from everyday worries, knowing that perhaps it's all just data. Let your mind play with the delicate threads of reality, the possibility that the universe is a grand computational masterpiece. Whether our reality is fundamental or simulated, the sheer possibility forces us to consider the sheer scale and variety of existence. What if there isn't just one reality, but an infinite number, all playing out simultaneously, beyond our wildest imagination, beyond the observable universe? The vast cosmic expanse our telescopes can probe stretches an unimaginable, perhaps infinite realm of space and time. What lies beyond our cosmic horizon? According to some of the most compelling and mind-bending theories in modern physics and cosmology, the answer is not simply more of the same universe. Instead, it suggests a boundless tapestry woven from countless other universes, each with its own unique history, its own set of unfolding events, and perhaps even its own fundamental physical laws. Imagine a cosmic foam, bubbling with an endless array of self-contained realities, each distinct yet part of a grander whole. This profound concept is encapsulated by the various multiverse theories, which propose that our universe is just one among an enormous, perhaps infinite, number of universes. These theories arise from different branches of physics, each offering a distinct level or type of multiverse. The simplest, level 1, suggests that if space is truly infinite and uniform, then beyond our observable horizon, identical copies of ourselves and our universe must eventually recur by chance. The level 2 multiverse arises from concepts like eternal inflation, where different bubble universes bud off, each potentially with different physical constants, dimensions, and laws. And then there's the level 3 multiverse, perhaps the most mind-bending, the many worlds interpretation of quantum mechanics. This view posits that every quantum measurement, every time a wave function collapses, the universe doesn't just choose one outcome. Instead, it splits into multiple parallel realities where every possible outcome actually occurs. In this interpretation, all the choices you didn't make, all the paths not taken, exist in parallel universes, branching endlessly. The implications of a multiverse are staggering and radically expand our cosmic perspective. It offers elegant, albeit unproven, solutions to some of our deepest mysteries, such as the cosmic fine-tuning problem. If countless universes exist, each with different physical laws, then it becomes statistically inevitable that at least one would have the precise conditions necessary for life. However, the multiverse also raises profound philosophical questions about identity, probability, and the very definition of reality. Are these other universes truly real, or are they merely theoretical constructs? The sheer scale of such a cosmos is almost too vast for the human mind to comprehend, yet it offers a strange, almost serene comfort in its infinite possibilities. It suggests that nothing is truly lost, and every possibility exists somewhere. Allow your mind to expand with the thought of countless realities, an infinite cosmic tapestry gently unfolding. As we contemplate these infinite parallel realities, these countless expressions of existence, we arrive at the most intimate and profound mystery of all, the nature of our own conscious experience. If everything else is a cosmic secret, then what about the self that observes it all? The very awareness that allows us to ponder these mysteries. At the very core of your being, in the intricate neural networks of your brain, billions of neurons fire in complex patterns, creating thoughts, feelings, and memories, the entire rich tapestry of your inner world. Neuroscience has made incredible strides in mapping these brain activities, identifying which regions activate during certain experiences. We can correlate brain states with experiences, but despite all this progress, we are still faced with the most profound, fundamental question of all. How do these purely physical processes, this electrochemical ballet of neurons, give rise to the subjective, inner experience of being you? Why does it feel like something to see colors, hear sounds, or wonder about the universe? This is what philosophers and scientists refer to as the hard problem of consciousness, a term coined by David Chalmers. While neuroscience can explain which brain regions activate during certain experiences and how sensory information is processed, it fundamentally struggles to explain why there is any experience at all. The qualitative, subjective nature of our inner life, known as qualia. Why does red look red? Why does pain feel like pain? Why do we have a subjective first-person perspective? There are several competing philosophical and scientific approaches. Some theories propose that consciousness is an emergent property of complex neural networks, meaning it simply arises spontaneously once a certain level of complexity is reached. Other theories, like panpsychism, suggest that consciousness, or at least proto-consciousness, is a fundamental property of the universe, woven into the very fabric of reality at its most basic levels. Still others believe that consciousness might be something else entirely, perhaps a non-physical phenomenon interacting with the brain, or something beyond our current scientific framework. The implications of this ultimate mystery are deeply personal and universally profound, challenging our understanding of mind, body, and the very fabric of existence. Can artificial intelligence ever truly be conscious, or just simulate it? If consciousness is merely an emergent property, does that diminish our sense of unique selfhood, our free will? What does it mean for death if consciousness is more than just brain activity, if it persists in some form? And conversely, if it is entirely dependent on the brain, what then? This is the ultimate cosmic mystery, for it is through this very awareness, this unique, subjective experience of consciousness, that we are able to perceive, to question, and to ponder all the other mysteries of the universe we have explored tonight. It is the vessel through which all cosmic understanding flows. Take a moment now, not to think, not to analyze, but simply to be, and to feel the quiet, profound mystery of your own existence, your own awareness, a silent miracle in the heart of the cosmos. And so, as we gently conclude our long journey through these 15 profound cosmic mysteries, we find ourselves back where we began, staring into the vast, beautiful, echoing unknown, both outside in the limitless reaches of the cosmos and within the depths of our own minds. Allow these questions, these profound and sometimes unsettling inquiries, to gently echo in your thoughts, not as burdens to be solved, but as soft invitations to wonder, to contemplation, and to peace. Let the quiet contemplation of the universe's deepest secrets, the acknowledgement of what remains just beyond our grasp, guide you into a profound and peaceful rest. The definitive answers to these grand questions may forever elude us, remaining whispers on the edge of perception, but the questions themselves are a timeless and beautiful lullaby. Sleep deeply, breathe slowly, and dream of the infinite.